You are standing on the southernmost edge of Europe. The place is called Tarifa, on the coast of Spain. Here, the wind is a physical presence, a relentless force that scours the landscape, carrying the sting of salt and ancient dust. Before you, a mere 14 kilometers of shimmering, restless water. And across that water, the other shore seems so close, you feel you could almost reach out and touch it. You see mountains carving the horizon. But these are not just any mountains. They are the Rif Mountains of Morocco. You see the white flecks of houses, the unmistakable outline of a civilization. You are looking at Africa.
14 kilometers. It is less than the length of many city marathons, a distance a strong swimmer could conquer in just a few hours. On a clear day, with a good pair of binoculars, you can distinguish the glint of automobiles moving along the highways of another continent. And in that moment of profound connection, a question is born. An inevitable, logical, almost angry question. Why? Why is there still no bridge here?
Humanity builds towers that pierce the clouds. We carve tunnels through granite Alps and beneath frozen fjords. We connect islands separated by dozens of kilometers of wild, open sea. We threw a bridge across the Golden Gate. We dug the Eurotunnel. We built the Millau Viaduct, whose piers stand taller than the Eiffel Tower itself. Yet here, in this strategic throat of the planet, where two worlds nearly touch, there is only a yawning, empty space. This is not for a lack of imagination. For decades, even centuries, engineers, politicians, and futurists have dreamt of this very project. A bridge between Europe and Africa, the undertaking of a century. A structure that would rewrite global economics, binding two worlds with a steel artery, redirecting the very flow of trade and tourism. Plans were drawn, budgets were calculated. Since the 1970s, Spain and Morocco have been in negotiations, forming joint committees, commissioning fantastically expensive studies. Sonar-laden survey ships have spent decades ghosting across this narrow strait, methodically scanning its floor. And each time, the project was quietly shelved. The deadlines shifted, from 2020 to 2030, and now, near total silence.
What could possibly stop a civilization that plans to build bases on the moon? Is it merely money? Is it impossibly complex politics? Or did the same engineers who raised the Burj Khalifa simply lose their nerve before 14 kilometers of water? What if the truth is far more unsettling? What if those survey ships, scanning the depths, discovered something that compelled them to cut their engines and return to port with a new, unspoken mandate of silence? What if these waters conceal a secret that renders construction not just difficult, but absolutely impossible? A fundamental veto issued not by man, but by the Earth itself. The investigation a secret hidden in plain sight. It begins, as these things so often do, with a dream.
The Romans of antiquity gazed upon this strait not with ambition, but with a kind of sacred dread. They called it the Pillars of Hercules. On one side, the Rock of Gibraltar in Europe, which they knew as Calpe. On the other, Jebel Musa in Africa, their Mount Abila. According to their myths, the demigod Heracles had not discovered this passage. He had created it, tearing the mountains asunder with his bare hands to forever join the Mediterranean with the great Atlantic Ocean. And upon the twin peaks, he set his two pillars as a monument and a warning. Inscribed upon them were two words of absolute finality: Nec plus ultra. Nothing further beyond.
This was not merely a geographical marker. It was a psychological barrier. The very edge of the known world, beyond which lay only monsters, chaos, and the abyss. But for the modern engineer, a limit is not an end. It is an invitation. The idea of a bridge across Gibraltar is not new. It was a fantasy whispered in the salons of the 19th century. Yet it was not until 1979 that the dream took on the weight of reality. At the very height of the Cold War, a time when the world was violently divided by ideology, two kings reached across the water. King Juan Carlos I of Spain and King Hassan II of Morocco signed a historic joint declaration. They would defy the ancient warning. They would make the dream manifest. Two joint committees were forged, entities that exist to this day. SECEGSA in Spain and SNED in Morocco. Their singular, obsessive purpose to study, design, and ultimately realize the impossible. Engineers from across the globe submitted their visions. It was a contest of scientific fantasy. There were plans for a colossal suspension bridge, with support towers so tall the world had never would have to stretch for more than 3 kilometers, a leap of faith twice the length of any bridge then existing on Earth. There were plans for hybrid structures, part anchored to piers, part suspended on cables. There were even audacious proposals for a submerged floating tunnel, an artery of glass and concrete tethered to the abyss, allowing ships to pass unhindered overhead. The economic promise seemed boundless. A direct road and rail link between two continents, a high-speed train that could whisk passengers from Madrid to Marrakesh. Cargo from the heart of Africa could reach European markets in mere hours, not days. It would be a new Silk Road, forged not of silk and spice, but of steel and fiber optics. It would connect Africa's burgeoning electrical grid, particularly the immense solar potential of the Sahara, directly into Europe's power-hungry network. Tourism would not just grow, it would detonate. This would be more than a bridge. It would be the defining landmark of the 21st century. And so, the engineers set to work. Before any concrete could be poured, before any steel could be forged, they first had to draw a map. Not of the surface, but of the secret world below. What precisely was down there? We are accustomed to thinking of a strait as a simple, U-shaped depression, a flooded valley. The engineers expected to find a relatively smooth, rocky bottom, perhaps at a depth of 50, maybe 100 meters. They dispatched hydrographic vessels, ships whose hulls bristled with multi-beam echo sounders. They began their slow, methodical dance across the waves, pinging signals into the crushing dark, listening for the echoes that would paint a three-dimensional picture of the terrain. What slowly materialized on their monitors was the first profound shock. It was not a valley. It was a nightmare. The floor of the Strait of Gibraltar is no gentle trough. It is a vast, violent, and jagged underwater landscape. It is gashed by colossal canyons, scarred by deep gorges, and defined by sheer, terrifying cliffs. But the topography, as chaotic as it was not the fundamental problem. The problem was the depth. At its narrowest point, a mere 14 kilometers of open water separating the continents, the floor gives way. It plummets. It falls to a staggering depth of 900 meters, almost a full kilometer straight down. Let that number settle. 900 meters. This was not merely deep. This was a geological chasm, a wound in the Earth's crust. The ancient warning, nec plus ultra, Siron Way, understood. That this was not just a gap between continents to be easily bridged, but a place where the planet itself warns us of its raw and untamable power. It is, in the simplest terms, an engineering impossibility.
Consider the Burj Khalifa, the tallest skyscraper on Earth, a spire of glass and steel reaching 828 meters into the sky. You could take that monumental structure, the pinnacle of human construction, and sink it into the narrowest part of the Strait of Gibraltar. Even then, you would still have over 70 meters of dark, churning water rushing above its highest point. To construct the foundations for a bridge in such a colossal abyss, it defies the very limits of our technology.
And only then beginning the actual work of building the bridge itself. At that depth, the water exerts a pressure of 90 atmospheres, a force that would crush It was dead on arrival.
But engineers are a stubborn breed. They refused to surrender. Poring over bathymetric charts, they looked further west, where the strait widens to 25 kilometers. And there, they found a feature that looked promising. A place known as the Cameronal Sea. Geologically, it is a place of almost mythic significance. It is the remnant of a colossal prehistoric dam. 6 million years ago, the Mediterranean Sea vanished. It became a vast, desiccated salt canyon, its floor lying nearly 3 kilometers below the level of the world's oceans. And then, 5.3 million years ago, the Atlantic breached the dam. It was, without exaggeration, the single greatest flood in the known history of Earth. A torrent of water, 1,000 times the volume of Niagara Falls, thundered through the gap, refilling an entire sea in what geologists believe was a span of mere years, perhaps even months. The Cameronal Sill is the eroded crest of that ancient waterfall, an underwater ridge connecting 2 continents, the shallowest path. Finally, it seemed, a solution. The depth here is only 300 meters. 300. But shallow is a relative term. To put that into perspective, the piers of the famed Mial Viaduct in France, the tallest in the world, rise 343 meters into the air. We would have to build their equal, but in reverse. Constructing them in total darkness, under monstrous pressure, before a single piece of the bridge even touched the surface.
Yet the engineers of the 1980s, flush with their recent triumphs taming the North Sea, declared it was possible. At the absolute edge of possibility, they admitted, it would cost more than the entire Apollo program, but it could be done. They were ready. Geological survey ships moved into position, their crews confident. They lowered their drilling equipment, ready to confirm the solid bedrock needed to anchor their Titan. The drill bit descended through the water column and touched the bottom. And then it simply vanished. It plunged into the seabed as a hot knife slides through cold butter. What they found was not rock. It was not clay, nor gravel. It was a substance the geologists gave a specific, almost ominous name: fangar. The geological term is unconsolidated Pleistocene fanglomerate. In layman's terms, it was Xi the relentless current. This wasn't a foundation. It was geological quicksand. A treacherous slurry, tens, and in some places, hundreds of meters thick. It was the second and final death blow to the project. You cannot anchor a structure weighing millions of tons to waterbed. The entire foundation would not just sink, it would flow, swallowed by the ancient shifting mud at the bottom of the sea. The strait had revealed its final secret. It is not the depth of the water that makes the crossing impossible. It is the very ground beneath it. A silent, potent reminder that for all our ambition, the Earth is built upon forces and timescales we can barely comprehend, let alone conquer.
Under any lateral pressure from a current or, heaven forbid, from an earthquake,
This unstable seabed would instantly enter a state of liquefaction. It would lose all its load-bearing capacity. The foundation would simply topple.
But why? Why is the seafloor here so profoundly treacherous?
This is the point where the engineers had to step aside and yield the floor to the geologists. And what they uncovered was no longer a simple problem. It was a verdict. The map the geologists produced was not merely a chart of the seabed, it was a map of the tectonic plates themselves. And it revealed that the Strait of Gibraltar is not just a passage between continents. It is a scar. It is a fault line, a place where the very plates on which we live are locked in a continuous, slow-motion catastrophe.
This is the Azores-Gibraltar Transform Fault, and it is not a simple line. It is a complex zone of collision, a tectonic knot where the Eurasian plate, the African plate, and a tiny microplate called the Alboran all meet, and they are grinding each other into dust. Africa, right now, in this very second, is moving north, ramming into Europe at a speed of about 4 to 5 millimeters a year. That is the speed at which your fingernails grow. It seems impossibly slow. But on the scale of geology, it is a furious sprint. The Rif Mountains in Morocco and the Baitic Range in Spain are the direct result of this collision. They are the wrinkles in the planetary carpet that Africa is relentlessly pushing northward.
The engineers were, in effect, proposing to build a bridge in the middle of a car crash, during the crash. And this is not just about slow movement. This fault line accumulates stress for years, for decades.
To understand what that means, we must take a step back in time, to the 1st of November, 1755, Lisbon, Portugal. A clear autumn morning. It is All Saints' Day. The city's magnificent churches are filled with tens of thousands of worshippers. Thousands upon thousands of candles have been lit. At 9:40 in the morning, the earth heaved. This was no ordinary tremor. This was one of the most powerful earthquakes in recorded human history, with a magnitude estimated today at between 8.5 and 9. The epicenter was not in Lisbon, it was out there, in the Atlantic. Directly on the Azores-Gibraltar Fault. The shaking lasted for somewhere between 3 and 6 minutes, an eternity. Fissures 5 meters wide opened up in the city streets. Cathedrals, palaces, libraries, everything built by host stones of their own civilization. Those who survived in open spaces ran in terror towards the harbor, towards the Tagus River, desperate to get away from the falling buildings.
And there, they witnessed a miracle that would become their curse. The ocean retreated. The water pulled back, exposing the floor of the harbor, littered with the wreckage of ancient ships and lost cargo. Then, 40 minutes later, it returned. It returned as a wall. 3 gigantic tsunamis, some reaching 20 meters in height, slammed into the city. They scoured the waterfront clean. And what the waves did not take, fire did. The thousands of overturned church candles started a firestorm that completed the annihilation. The city burned for 5 days. In Portugal, Spain, and Morocco, the death toll may have reached as high as 100,000 souls. This is the power coiled beneath the strait, a sleeping giant whose slow, steady breath shapes mountains and whose occasional violent shudder can erase cities from existence. It serves as a humbling reminder that our grandest designs are but fleeting sketches on a canvas that is alive and unimaginably powerful. The shock wave, a tremor felt in the very bones of the earth, reached as far as Finland.
A resulting tsunami, born of the same cataclysm, inflicted damage in Ireland and across the ocean in the Caribbean. It was a catastrophe that fundamentally altered European philosophy, a violent convulsion that gave birth to the modern science of seismology. And its source was the very same fault line, the same restless seam in the planet's crust, where engineers once proposed to build a bridge.
The question is never if. The question is always, and only, when. The United States Geological Survey is предельно, devastatingly clear on this point. This fault is active and judged to be extraordinarily dangerous. Any structure built over it, any monument to human ambition, must be designed to withstand a magnitude 9 earthquake and the direct impact of a 20-meter tsunami. So, how does one build a 14-kilometer bridge whose support piers must stand in 300 meters of water, anchored in a gelatinous mire, all while straddling a tectonic boundary that is guaranteed to shift beneath it? The answer is simple. You do not. It is a physical impossibility.
But let us suppose, just for a moment, let us suppose we have lost our minds, that we have found the trillions of dollars required and invented some magical, impossible materials. Let us, for the sake of argument, ignore the certainty of the earthquake. What other secrets does this water hold?
This is not merely water. The Strait of Gibraltar is a planetary fire hose. It is the sole choke point where two colossal bodies of water wage a timeless, silent war. In one corner, the cold, less saline Atlantic Ocean. In the other, the warm, supersaline water of the Mediterranean Sea. And why is it so salty? The Mediterranean is an enclosed bowl in a hot, arid climate. Water is torn from its surface by evaporation at a staggering rate, but the salts are left behind. Its sea level would fall by a meter every single year were it not for the lifeline of Gibraltar.
And this is what happens. On the surface, a colossal river of Atlantic water pours into the Mediterranean to replenish what the sun has taken. It moves at speeds of up to 5 or 6 kilometers per hour. The volume of this inflow is nearly 1 million cubic meters every second. But that is only half of the story. Beneath this surface river, the dense, heavy, salt-laden water of the Mediterranean sinks to the abyss. It has to go somewhere, and so it does. It bleeds back out into the Atlantic, a vast and powerful undercurrent flowing in the opposite direction.
These are two gigantic rivers, stacked one atop the other, moving against each other in a perpetual, violent ballet. This dynamic creates currents of unimaginable force. At the seabed, 300 meters down, the water rages with a velocity capable of knocking a submersible clean off its course. These are the very currents that have scoured the seafloor for millennia. But the most terrifying phenomenon in these depths is something else entirely. They are called internal waves.
These are not the waves you see on the surface. These are gargantuan, 100-meter-tall tsunamis that move silently, invisibly, beneath the waves, at the boundary where the two layers of water meet. You cannot see them from a ship, but satellites can track their ghostly passage across the strait. They are generated when the powerful tidal flow from the Atlantic slams into the submerged Cameronal sill. These underwater monsters, these silent behemoths, would not just lap at the piers of our hypothetical bridge. They would slam into them with focused, cyclical fury. They would create vibrations and stress loads that no known material could ever hope to endure.
To even attempt to work in such conditions, to descend 300 meters into absolute crushing darkness, into a world of unseen currents that places on this earth not meant for our grand designs. There are forces at play that do not bend to human will, boundaries that exist not as a challenge to be overcome,
but as a humbling testament to a power far greater than our own.
In the icy water, within a current so ferocious it tears robotic submersibles from their tethers, engineers face a Sisyphean task. They are attempting to pour a foundation into a seabed.
And yet, this engineering purgatory is a paradise for life. This strait is not merely a waterway. It is a faunal corridor of immense significance. It is the primary migratory route for the titans of the sea, the cetaceans. Enormous fin whales, the second largest animals on our planet, glide through these turbulent waters. Giant sperm whales dive into these very same submarine canyons, plunging thousands of meters into the crushing blackness on their hunt for an almost mythical prey, the giant squid, Architeuthis. The very presence of these deep-water predators tells us that the canyons of Gibraltar are a wild, largely unexplored territory, a frontier at the edge of our own world.
Here too live pods of orcas. But these are not just any killer whales. They are a unique, isolated Iberian subpopulation. And in recent years, they have become infamous across the globe for a strange, unsettling, and entirely new pattern of behavior. They are purposefully attacking sailing yachts. They ram the rudders, splintering them with focused, intelligent force. And sometimes, they sink the vessels entirely. Scientists cannot fully explain this behavior. Is it a form of play? An act of revenge for some unknown slight? Or are the elders methodically teaching their young a new, disturbing lesson? It remains a profound mystery, but it is a stark example that in the Strait of Gibraltar, the rules are not set by man.
The truth is, no single whale or orca could ever pose a threat to the colossal pier of a modern bridge. But their presence, their ancient power, it underscores just how complex and untamable this ecosystem truly is.
Was there another way to conquer this strait?
Oh yes. And it was born from an ambition far more insane.
In the 1920s, a German architect named Hermann Sorgel proposed a project known as Atlantropa. His idea was not to cross the strait, but to close it. Sorgel proposed building a gigantic hydroelectric dam across the Strait of Gibraltar. This would, firstly, provide Europe with a near-limitless supply of cheap energy. But secondly, and this was his primary objective, it would begin to drain the Mediterranean Sea.
According to his meticulous calculations, the water level would fall by 1 meter per year. Over the course of a century, it would drop by 100 meters. In 2 centuries, 200. This would expose 660,000 square kilometers of new, fertile seabed, a territory larger than the whole of France. He planned to unite Italy with Africa by a new expanse of dry land. He dreamed of Euro-Africa, a new supercontinent forged by human will. The project was incredibly popular in the 1920s and 30s, worked out to the smallest detail.
Thankfully, it was never realized. The consequences would have been catastrophic. The shifting weight of trillions of tons of water on the planet's crust would have triggered unpredictable earthquakes and volcanic activity. The climate of Europe would have been altered beyond all recognition. It would have been an ecological disaster on a planetary scale. This mad but very real project shows the obsession this place has always inspired in us. The sheer, breathtaking hubris.
At that moment, the engineers seemed to say, "All right, we understand. A bridge is madness. The earthquakes, the depth, the mud, the current, it's too much. A dam is a world-ending insanity. Forget them both." But W.
There was, of course, another plan. If one cannot build over the strait, then perhaps one could build under it. The idea was to burrow a tunnel deep beneath the turbulent waters, a silent artery connecting two continents.
The Eurotunnel, linking Britain and France, had proven such a feat was possible, but its success was owed to a single, extraordinary fact. The geology was a gift. Engineers bored through a single, stable, impermeable layer of chalk marl, its shape, and kept the water out.
Gibraltar is the worst place on the planet to attempt such a thing.
Here, you are not merely digging under a channel. You are attempting to conquer an abyss. First, you must descend beneath 900 meters of crushing water pressure. Then, you must bore through hundreds of meters of an unstable seabed known as the Flysch Group, a treacherous, semi-liquid ooze that offers no solid foundation. But the true nightmare, the project's absolute executioner, lies deeper still. You must drill directly through the Azores-Gibraltar Transform Fault. The geology beneath the strait is not hard cheese. It is what geologists call, with a kind of grim reverence, an accretionary prism. It is a chaotic, nightmarish jumble of rock that has been shattered, tunnel-throughs, and clay, while two giants are violently shaking the sack back and forth. You simply cannot lay a tunnel across an active fault line. The moment the plates shift, and they will shift, the tunnel would be sheared in two, as easily as snipping a paper straw. Millions of tons of water would erupt into the breach in an instant. It would not be an engineering failure. It would be a tomb. Very well. What about Plan C? What if, instead of drilling through the seabed, we built a tunnel that floats within the water itself? A colossal concrete tube, suspended 50 to 100 meters below the surface, held in place by massive tethers anchored to the seafloor. This is a real concept, a submerged floating tunnel. Norway is currently experimenting with this very technology for its fjords.
But fjords are placid, sheltered lakes compared to the maelstrom of Gibraltar. The first question is immediate. To what would you anchor these tethers? Infamous 100-meter internal waves due to this buoyant tube? They would whee.
And finally, there is the surface. The Strait of Gibraltar is one of the busiest shipping lanes in the world. More than 100,000 vessels pass through it every year. 300 behemoth tankers and container ships churn its waters every single day. Now imagine one of them loses power, loses control, and its anchor, weighing many tons, breaks free from its chain. It plummets down through the water, a steel spear aimed directly at your floating tube. The result is not a leak. It is a cataclysm.
And so, we arrive at the end. We see why the bridge and the tunnel will never be. It is not one single insurmountable problem. It is a perfect storm of engineering impossibilities, a conspiracy of nature itself. The incredible depth, reaching 900 meters, makes support piers a fantasy. The unstable seabed, a slurry of mud hundreds of meters deep, refuses to bear any weight. The demonic, two-layered currents and colossal internal waves generate forces beyond our capacity to withstand. And overseeing it all, the active tectonic fault line, a guarantee of a magnitude 9 earthquake and the colossal.
Nature, it seems, has used its entire arsenal here. It has erected 4 walls around this place that we simply cannot breach. In their final reports, the engineers, the dreamers, the builders were forced to concede defeat. The Gibraltar Strait Crossing Project is, for all practical purposes, dead. It surfaces in the news every few years, a ghost conjured by political promises.
but no serious engineer entertains the notion any longer. Some places, it seems, were not designed for human ambition. They exist as they are, permanent and powerful reminders that for all our genius, we are still subject to the planet on which we live.
A gap of just 14 kilometers. It is not merely water. It is a gateway, the fabled Pillars of Hercules. In the ancient myths, these pillars were not erected to be connected, but as a solemn warning, inscribed with 2 words, Nec plus ultra. Nothing further beyond.
We can travel to Mars. We can edit the very building blocks of life. Yet we cannot build a bridge across the Strait of Gibraltar. It seems we have found the limit beyond which we cannot pass, because here, the planet Earth, a living, breathing, and moving world, has drawn a line in the sand. In this one specific place, it has simply said, no. Is the task truly impossible, or are we merely waiting for a technology then that sleeps on the seabed below? Should we even dare to try?